All right, so now that everything's calibrated, we are ready to start our scan. So in order to even start your scan, you already have to have an inspection. So I've got an object that I've previously inspected on here, and I'm going to go up to the inspection tab, which has today's date, and I'm going to select Profiler Recording. All right. Now if we scroll down, just like with the diameter measurement we talked about in one of our previous videos, we have to select the nominal diameter, which means roughly how large is it. I know that this is less than 20 inches, so I'm going to go ahead and select that. Our lights are going to turn off, our lasers turn on, and we've got our barcode on there. So when you do a scan, there's a couple of things to keep in mind. Ideally, this is done under dry conditions. A little bit of water on the pipe won't skew your results too bad, but a large amount of water could cause really, really bad data. You also want to make sure it's dark. You don't want to be doing it in a line that has a lot of light coming in, because it's going to use these lasers that are on the screen here to actually calculate all of our data, and any light can skew those. You want to make sure your barcode's on here. So down in the bottom right of my video, we have those two bars. We haven't started recording yet. So those will go ahead and start filling in as we do our recording here. And then you also want to make sure you have your speed and your distance on there, which is represented by our LC1 here, and our V stands for our speedometer there. So a couple of things to keep in mind. It is recommended to do these scans at between 1 to 2 inches per second. Any faster than that could skew your data. The other thing to remember is that you're going to do this after you've already done your inspection. So you start at the end of your section and pull it back while it's doing this. So scrolling down here, we've got a bunch of checkboxes that have to be hit. These are all necessities to be able to go ahead and get the best results you can out of the scan, and we have to hit them before we can even start the scan. So camera calibrated, yep, we already went ahead and did that. Camera positioned centrally to the pipe wall. For ideal data, your camera head will be centered in the pipe. If not, it'll make your pipe kind of look funky when we go and look at those cross sections. That may take a mix of equipment like a lift or a horse. Really, you're just going to want to identify how large your pipe is and what you have to do to get your camera centered in there. Dry and dark, yep, we've got it in there. 2 laser dots centered and barcode to see in the bottom right corner. Check and check, we got those. And then exclusively the distance counter and speed at the bottom left corner. We have those on there as well. So once we're ready to start our profiler recording, we go ahead and press the red recording button right here. And our camera head's going to then begin to rotate. So sometimes you'll hear this referred to as a spiral profile analysis. It's because our camera head is spiraling as we pull it back, creating kind of like a slinky shape, which when all put together by the software goes ahead and creates a full cylinder and gives us a good idea of what the pipe is. So at this point, you would just go ahead and begin to pull back the entire length of your pipe. And that's it. Just keeping an eye out for your lasers disappearing, nothing major. Once you're done with your scan, you go ahead and press the blue square down here at the bottom to stop our recording. It's going to say the profile analysis is stopped. We're going to hit OK. And now we're going to go ahead and close our profile recording. So as you can see here on our object information page, we have a profile analysis tab. This is where we're going to get into the next step, which is processing all of our data and making sure that our scans are looking good and have, ovality, cross-section reduction, all that data that we're actually looking for. All right, so our profile analysis has finished. And you can tell because we have some data popping up in here. I already had some graphs ready to go. So we're going to go ahead and close this out. And the next thing we're going to do is we're going to take a look at our reference profile configuration. So this data is already filled out because I've done this before. But in here, when you open it up for the first time, it'll have your height, it'll have your diameter, it'll have distance that you, whatever specific cross section you're looking at here, as well as diameter. And then you have your reference profile down here at the bottom. So if we click on circular profile, we have a couple of different profile types to select from, and this is really important to select the correct one because it's what the rest of your data is going to be based off of. So I'm going to go ahead and select circular profile for this, but just as a quick overview, we have ovoid in 3 different versions, and then we also have cross section. So if you're doing a non-circular or non-ovoid pipe, or it's just not a conformed pipe, you may select a specific cross-section by clicking on the graph down here at the bottom, and you can set that as your ideal data point, and it'll generate the rest of the data around that. So I've got my reference profile here selected. I'm going to go ahead and close this out, and we're going to go ahead and take a look at graphs here. So I'm going to skip right over this button here and go to the wrench, and if you hover over it, it says Profile Analysis Settings, and we'll go ahead and open it up. So there's a lot to cover in here. So first we have the cross-section header up here at the top. This is referencing here. If I hit any of these boxes here, it'll go ahead and turn those specific things off here. Now let's go through each one of these options. So first we have measurement points and curves. So if I turn this off again, you can see that that's referencing all that blue on there, all those blue hash marks. That is what the scan actually measured while you were scanning. So that's your actual data. And each one of these cross marks here is showing you an individual data point that was taken. So we've got really good uniform spacing between these. This looks like a very good scan. We have mask data, so this will control whether or not your mask data shows up on here, and we'll go over masking here in a minute once we finish this graphing section. And then we also have reference profile, so if I click on a less ideal section here than what we were looking at, you'll see this black circle. That's our reference profile there. That's what we just set in our reference profile configuration, and that is just setting your ideal pipe. It's letting you know, hey, if this was perfect, this is what it would look like. And then down here at the bottom, we have camera position, which is represented by this star. Like I said when we did our scan earlier, you want to do your best to be centered in the pipe. Now we're looking at a cross section here, so this is actually what your pipe should look like if you were to crawl inside. And this black star represents your camera position. So if we just click through a couple spots through here, it looks like we did a pretty good job about staying centered in the pipe pretty much the entire time. So that's looking really, really good. Report configuration, so we have a couple of different options on here. We have masking in the cross-section report, so again showing your masking on here, and then masking the profile report, which is the total report down here. These are settings that you're setting for when you go to export out your data as a PDF, and you can set a specific reference profile on here, and that's what it'll print out when you go to show your section. If you need multiple sections, we'll cover how to do individual cross-sections here in just a minute. Moving on, we're going on to our section profile graph down here at the bottom. So just brief overview of what we're looking at here. So we're looking at the name of our graph here. So right now it's named cross-section reduction. I could click on this and change this to anything. I could make it say ovality, and if I hit enter, it'll go and say ovality, even if it's not displaying that data. So don't feel like you're stuck by naming it these references here. You can really name your graph whatever you would like. I'm going to go and change this to cross-section reduction though, because I'm very particular. Or we're going to name it reduction of cross-section again, just to keep in line with what our graph is displaying. Great. Oh, go ahead and delete that little slash there, get that out of the picture. All right. So underneath that we have reference. So this is saying it is how your data is going to be relayed to you. So right now we're looking at a reduction of cross-section underneath the reference of reduction of cross-section. If I go ahead and change this to something completely different like width, this data skews immediately. And that's because it's looking for reduction of cross-section data. It's showing that, but your graph here is set to show your width. So we don't really want to do that. You want to try and keep it the same as the data you're trying to show on here. Down here we have upper boundary and lower boundary. Those are represented by these dashed lines down here. And you can set these so that you can show if you're looking for like a specific data range. Like a lot of times people are looking for like a 5% change in ovality. We can go ahead and set these here so that you can tell just by looking at it, well, we don't have anything that's over 5% ovality there. And then you also have your quantile. So that goes ahead and takes an average based on your data. So on average, for 50% of this, we have a 0.14% reduction of cross-section. I could do this to show what the 90th percentile is. So 90% of the pipe has a 0.88% reduction of cross-section there. So down here we have all of the different graph options available to use. So right now we've got reduction of cross-section, but we also have ovality, diameter, height, width, perimeter. And we can go ahead and turn all these on if we want and overlay them on top of each other so that you can look at two graphs at once. You can turn on just some of them, really whatever you want to do. I recommend only doing one graph at a time. And that to me is just because it makes things a lot less messy when we go to look at it here. So I'm actually going to go ahead and turn off all these other graphs here. Now, you might be saying, well, how do I show both graphs? Well, that's an excellent question. So what you're going to do is you're going to come up here to this name, and you're going to press this Add New Profile Graph button, and that's represented by this green plus mark right here. And it's going to go ahead and ask us what we want to name our new graph. I want to name our new graph ovality because that's what we're going to go ahead and do. All right, so you can tell that this automatically changes our data, and it looks way different. And that's because of a setting that we haven't talked about yet. So I'm going to go ahead and set ovality down there at the bottom. Now, the reason this looks so skewed is because we have this one section right here that is showing a 12,000% increase in ovality. And if we look here, we can tell that this data is wildly wrong. So this means one of two things. Either your pipe is wildly deformed or something went wrong with this position in the scan. Now, I know that this is the beginning of my section, so I know that I was a little bit into the manhole. I drove back a little bit too far when I did this scan, so that kind of skewed because it picked up some of the manhole data and it makes everything look way different than what it really is. But I don't want this outlier here to be the benchmark for how the rest of my data is measured up. So what I'm going to do is I'm going to click on relative axis down here at the bottom, and it's going to give us the options to change these X and Y values on the sides here. So specifically, we're looking at this Y value here, the minimum and maximum value. So right now the minimum value is negative 5%, the maximum value is 1,213%, and that's just not good. So we're going to go ahead and I'm going to keep this minimum value because I want to know if anything dips below that 5% minimum. But I'm going to go ahead and change my maximum to something way more accurate. So we're going to go ahead and say 100%. All right, so you can see here that this went ahead and changed our data. So we still have a couple of spikes in here. But we still see that this outlier here is way too big. So I'm actually going to go ahead and go with what looks like to be the highest data point on here. Looks like 55%. And we're going to set this to 55%. All right, so now you can see that my graph has become much more manageable. I can see far more of this data. Now, I might click around on here and look at these specific cross sections, and I see, oh, hey, these have little bumps. They have little things that are sending these ovality measurements way out of the water, just making them super inaccurate. Now, I know from experience, and because I've seen the CCTV video of this line, that that's actually caused by taps in the line and a little bit of water in there just skewing those results. So I don't want those to continue to skew my results right here. There was a lateral at 2 o'clock there. So I'm actually going to go ahead and make my maximum value a little bit lower, and then we're going to go ahead and talk about masking. Exit out of this here. So the tops of these are cut off, and that's because they're still over the maximum value that the graph's showing. So I need to go ahead and mask these data points off so that I have a little bit more accurate data. So I'm going to go to mask measurement here. And we have a couple different options for masking on here. So we have add masking and automated masking. So if I click through and take a look at these little pipes here, yep, we got a little divot here. We had a little bit of debris. Something's going on here. Just stuff that's super explainable based on our CCTV video. I can go ahead and mask off these data points because I know it's just not accurate to what this measurement should really be showing. So the first way to do this is add masking. So once we click on add masking, it goes ahead and changes on here, and we have two options. We have two things that we need to do. We need to left click on our profile graph down here and select the section that we want masked off. So we'll click right there. So this whole section I'm going to mask off. And then we're going to come up to the cross section up here, and we need to select the amount of the cross section that we want masked off. So I'm going to go ahead and select this whole thing because I know that whole section was just not good. And it can be a little tricky sometimes to get that exactly right, but we'll go ahead and set it right there. and we're going to go ahead and press this green button, and that's going to go ahead and add our masking for us. Once we're done adding that masking, we're going to go ahead and hit End Add right underneath Set Masks. And you can see, we just saw in there that that section went ahead and disappeared, which is good. So we got a big problem off of our back there. But we need to go ahead and mask the rest of these. Now, if we take a look at these, you'll see that they're not at, uniform marks there, right? They're kind of all over the pipe, and that's because, most of our laterals were at about 2 o'clock. So we could mask off everything at 2 o'clock. We know that there was debris at the bottom, but we had this cross section right here where we had a lateral at 10 o'clock. That's not going to get caught if we go ahead and select this whole section for masking. So what we're going to do is we're going to select automated masking. So this is a little bit of a faster way to go ahead and mask off your data without being quite as precise. And the reason being is we are going to set a total range of data that is acceptable, and then anything on either side of that is going to go ahead and get masked off for us automatically. So it's asking for a maximum and minimum radius. So really easy way to get this is to go ahead and take your diameter and divide it by 2, and that'll give you your radius. So I know that my inner diameter should be about 27.51. That's what we're looking for. That's what ideally this is going to look like, and we want to mask off anything on either side of that. It'll take care of those deviations for us. But we need to set a range. So good rule of thumb, what I do, and this is completely up to you, is I take 10% of the radius and add that on or subtract that off the radius, and that's going to give me my maximum and minimum value. So for example, we're working with 27.51 here. We'll say 27.5 for easy math. If we divide that by 2, we're looking at 13.75 is our radius. So I'm going to take 10% of that, which is going to be 1.37, and I'm going to add that to the radius to go ahead and give me my maximum radius. So that's looking like 14, we'll say 15 to keep it easy. And then for our minimum radius, we're going to go ahead and subtract that. So we're looking at about, we'll say 12.5 for our minimum radius on here. So anything on either side of this data range is going to go ahead and get masked off. And we'll go ahead and create masks. It'll take a second. This bar will go across. And you'll see on here we have a bunch of red sections that have been highlighted. So it's not highlighting every section, but it is hitting those big deviations for us that we want taken care of. And if we go and look at the sections that it's hitting, it's those sections that are outside of those specific ranges, which is good. That's what we're looking for. So we're going to go ahead and hit Apply Maskings here, and it's going to go ahead and apply that data for us. So that's great off. You can see our big spikes have changed. If we hit Control and use our mouse wheel here, we can zoom in. So it looks like we're pretty close to this range. You might mask off this data set here if you can explain it. I really can't. It looks like we just have a couple, maybe a lateral here that got missed on the scan. Just a couple of things that may have been missed. So you might want to go back and use that add masking to just get precise data. Or maybe you've done your CCTV video and hey, there's no deposit there. Hey, there's no lateral there because these are all referenced by distance. If we click on a section and look over here, we have all of our data for that specific cross section. I know that this specific section of the pipe was at 82.59 feet, and that is going to be from your upstream entry point. Maybe these aren't explainable. Maybe these are just deviations in the pipe. That's why you want to have that CCTV as well. And that's what makes this a super powerful tool, because, if you're doing a manual testing, you might not see that this, specific cross section here is just a tick over that 5% mark that we're looking for. So again, just talking about super, super, super accurate data on there. Now that we've gone ahead and processed our data, it's time for us to move on to exporting it out. So you have the obvious option of selecting data transfer, going under your reports and adding that as a report. And that'll do your full profile graph, and it'll show you an individual cross section that we set over in our we set it in there. In our profile analysis settings, we set it for 65 feet. All right, it'll show this cross section at 65 feet. Alternatively, if you want to show multiple cross sections, you can go ahead and select a cross section down here at the bottom. So we'll say this one here. And then we come up to the printer button up here, and it'll print the cross section. So this is going to generate a page just like it would in your report. It's going to show you that specific cross section. It's going to show you that portion of the profile, and it's just one specific cross section that you can go ahead and work into a report. Or if this data wasn't generated originally and you need to add it later, or maybe you're in the field and you just need to print this off and hand it to somebody to show them a problem section. That's all available for you right here. We can come up here and hit this print button up at the top. And it's just going to come up with general print options. So you can print it if you have a printer connected. You can print it as a PDF. You can print it directly to your desktop, whatever you want to do. And you have, again, your regular print options, number of copies, print on both sides, all the pages that you want to print, all that good stuff on there. So once you're ready to print that, you just hit print right there, and it goes ahead and takes care of that for you. I'm done with this. I'm going to come up here to my cross section, and I'm going to click close, and that's going to close that cross section for me. There is one other option to export this data. We have this floppy disk represented by a CSV, it's a CSV export represented by this floppy disk. It says CSV at the bottom here, and that's going to export that out in a pure data format. So the specific individual measurement points and increments will be exported out in a raw data format. This would be useful for somebody that wants to do their own graphing with options that aren't necessarily available in IKAS, or for somebody that really wants to drill down into that hyper-specific information. All right, so now we have officially covered what it takes to do a laser profile scan, a profile analysis, a spiral profile scan. There's a lot of different names for it out there. But we have covered it from calibrating our ORPHEUS 2 camera all the way to exporting out this data here. If you have questions at any time about this process, or you want to drill down into something, there'll be the software department information at the end of this video. You can also reach out to your salesperson. And I want to say thank you for watching, and I hope you have a wonderful day.